All right, welcome back. This is lesson 19. In this lesson, we're going to be talking about value type of word problems, and then also the fact that angle also means angle, which is a geometry theorem, but we're still going to go over that in this class. So first, I want to talk about value word problems. And the important thing to remember when we're dealing with value word problems is we're more than likely going to have two unknowns, two variables, two types that we are talking about, and we're looking for two statements for our equations. One is going to be a question of quantity. How many are there? And the second one is going to be an issue of quality. What is their value? What is their worth? And so in our first example, we have Christian had 50 nickels and dimes. Okay, so right there, 50. That is dealing with quantity. Whose value was $4. That is dealing with quality. And we know that nickels are worth 5 cents and dimes are worth 10 cents. So there we also know value. How many of each coin did he have? So to help me organize my information, I am going to mark that down as an issue of quantity, and then the $4, and then also nickels and dimes when dealing with quality. And then from that, I can set up two equations because I do have two variables. I don't know how many nickels, I don't know how many dimes. So two unknowns means I'm gonna need two equations. And with nickels and dimes, this is where we're going to start using those subscripted variables that we talked about a couple of lessons ago with number of nickels and number of dimes. So for our first one, quantity, I know that the number of nickels plus the number of dimes is going to equal 50. So there's my quantity statement. And now my quality. The number of nickels plus the number of dimes is going to equal $4. But if we're dealing with value, I'm going to have to assign a value to each of these. I know that nickels are worth 5 cents, and I know that dimes are worth 10 cents. But if I'm dealing with cents, then my other part of the equation before, it needs to be in cents as well, not in dollars. So it's going to be 400. And this way, I don't have to deal with any decimals either. So that's another reason why we set this up. Looking at it straight up like this, I can plug this into my calculator for system equations, but I have to remember that I'm dealing with number of nickels and number of dimes, but my calculator program only knows how to work with X and Y. So if I am going to do that, I need to remember to switch that back at the end. I don't write my answer as X equals and Y equals. That's not what it's talking about. It's talking about nickels and dimes. We're going to go ahead and solve this for substitution. In this top equation, I'm going to get dimes by itself. I like to isolate dimes because when I plug it in, I'm going to be distributing by 10. Really easy to distribute. So this rewritten is number of dimes equals 50 minus number of nickels. And this is going to go right in here. So we have 5 times the number of nickels plus 10 times 50 minus number of nickels equals 400. Okay, looking at my equation, I only have one type of variable and it's number of nickels, so I am good to solve. I'm going to switch up colors. And so we have 5 times the number of nickels plus 500 minus 10 number of nickels equals 400. Add like terms right here. So it'll be negative 5 number of nickels, and we're going to subtract the 500 to both sides. So that is gone, equals negative 100. Divide by negative 5. So the number of nickels equals 20. But they also want us to find the number of dimes. So I'm going to take my answer for nickels, I'm going to plug it back into this original equation, and I find that the number of dimes is going to be 30 because 20 plus 30 equals 50. Okay, so this is my answer. We found both parts. It's always good to double check these types of questions. Read this part one more time and make sure that you have answered the question that they're asking for, because sometimes they will go off on a tangent that requires you knowing these two answers, but not necessarily is asking about these two answers. So our question was, how many of each coin did he have? He had 20 nickels, he had 30 dimes, so we are done. Our second example is not dealing with nickels and dimes. In this case, we're actually dealing with pence, and they are using pence to purchase codfish and mussels. So the fishmonger sold codfish for 6 pence each and mussels for 1 pence each. If Harriet bought a total of 26 items and spent 86 pence, how many codfish did she buy? So we're looking for quantity and quality. Quantity, I know that she bought a total of 26 items, and I also know that she spent 86 pence, and I know that we had 6 pence and 1 pence for the mussels and the codfish. So right there, I can start setting up my quantity, the number of cod, the number of mussels. I don't know what it was for each, but I do know that total, she had 26 items. So the number of cod plus the number of mussel will equal 26. So there is my question of quantity, how many were bought. My next question is a question of quality. I have my number of cod plus my number of mussel, and I know that she spent 86 pence. But I also have to apply a value to these because we're dealing with quality. How much did she spend? And I know the codfish were 6 each, the mussel were 1, so I don't have to write the 1 in front of there because it's just gonna be the same. So now, looking at this, I'm going to take this first equation, I'm going to isolate one of my variables. I'm going to isolate mussel. That way there's nothing that I have to distribute when I plug it into this equation. So the number of mussel equals 26 minus the number of cod. So we have 6 times the number of cod plus 26 minus the number of cod equals 86, and now we're just going to solve. So I'm going to, there's nothing, we have parentheses here, but there's nothing to distribute, so we can just disregard those. I'm going to subtract 26, and then I'm also going to add my like terms, and I'm going to end up with 5 number of cod equals 60. Divide by 5, and the number of cod equals 12. And looking back at the question, how many codfish did she buy? So I actually don't even have to take this and solve for number of mussel. They only want to know the number of codfish, and the answer is 12. So we're done. The second concept in this lesson is stating that AA also means AAA, meaning if we know that with 2 triangles, if we know 2 angles are congruent, 2 sets of angles, then we also know that the third set of angles is congruent as well. This is called the no choice theorem, just because we know that all 3 angles of a triangle have to equal 180. So we see that here we have 45 and 45, 105, 105, and 30 and 30. But let's say that we didn't know about this 30. We only know that 2 sets of angles are congruent, but because that they all have to equal 180, even though they only tell us 2 angles, we still know AAA, which means that these are similar triangles, and we can use that information to help us find the measures of different sides whenever they give us some measurements for our triangles. So let's go ahead and work on some practice. So let's take that theorem of AA means AAA, angle, 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 and let's go ahead and put that into practice. So here we have 2 triangles. We think that they're similar, but because we know that this set is congruent and this set is congruent, we also know that this third set of angles is congruent as well. So we do know that these are similar triangles, and I can use their measures to set up proportions and solve for X and for Y. I'm going to solve for them separately. I don't want to try to solve at the same time, but I can use this information and find our missing sides. So I know that 4 and 6 are the same side of the triangle, just in different triangle settings. So that's going to be the primary fraction that I work with. And so because I have 6 in my denominator, I'm going to have X in my denominator as well. And now I have to figure out which side on this triangle is in the corresponding place as X. And so x falls between our first and our second angle. So the side that falls between our first and second angle here is 5. And now we're going to cross multiply. So 30 divided by 4, we're always going to reduce. So this will be 15 over 2 equals x. Okay, so we found our first side. Now we need to find y. So when solving for y, we're going to set this up again with 4 over 6 equals, and we're going to put y in the denominator because 6 is in the denominator and they're from the same triangle. And then through process of elimination, we know that 7 is going to be the other number that we're going to use from this triangle. We're going to cross multiply and we're going to get 42 over 4, which reduces to 21 over 2. It's reduced to its lowest form, so 21 over 2. And that's it. We have solved for the 2 missing sides of this triangle using angle, angle, angle. And that's it. We're done. All right, so that's it for lesson 19, value word problems and angle, 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 and using that to find the measurements of missing sides of a triangle whenever you have 2 similar triangles. So I hope you guys got a lot out of this. We'll see you guys in class for questions. Make sure that you guys subscribe so you can get all these new videos as we keep posting them. I'll see you guys in class.